All right, look at this. We're at the last section of chapter 0, and then after this chapter, then we start into some real geometry. This has just kind of been preparing you for what's going to be ahead, because a lot of the things that we've been doing in this chapter 0, we're going to have to do in the geometry book throughout the book. All right, so that's why we did the chapter 0. All right, let's go through a couple rules here. This is on the top of page P19, right at the top of section 09. I didn't write these out. I'll read them to you and then give you like a little example. When we talk about simplifying radicals, you remember what a radical is? It's a square root is one radical, but that little mark right there, some people say, oh, it looks like a check mark, okay? Or sometimes they'll put a little thing here. Some people put a little thing here. This thing right here is called a radical. And if let's just stick with a square root. What if I put a number underneath of here? What does that mean? That means it's the square root of 4, which means what number times itself is equal to 4. So what times itself? Is 1 times 1? Nope. What about 2? 2 times 2? Yeah, 2 times 2 is 4. So the square root of 4 is 2. All right, so you should be a little bit familiar with those things. What I'm concerned about at the beginning of this is there's 3 rules that has to be followed when you simplify a radical. All right, so the first one says no radicands, which means the radicand is all the stuff that's inside of here. All right, so no radicands have perfect square factors other than 1. So what it means is this: if I had the square root of 16, is that simplified? No, because this is a perfect square, because I can take the square root of this and it comes out to a nice whole number. So this is not simplified. All right, this is a perfect square. There's a number times itself that actually equals this number right here. So that is not simplified. I would have to simplify it and get that. Okay, so do not leave your answer like this. That right there is not simplified. Okay, this would be simplified right here. So that's the first thing. The second one says no radicands, or the thing inside of the square root, contains fractions. So you can't have a fraction. So if I had the square root of 1 over 2, this is not simplified. All right, so this is not simplified. This is not simplified because you can't have a fraction inside of a square root. We'll talk a little bit later on how to simplify that. We won't do it right this second. All right, here's the third one. The third rule about simplifying radicals is that you can no radicals appear in the denominator of a fraction. You're like, well, I thought that's what that was. No, something like this. Watch, if I had like 3 over the square root of 5. Okay, for some reason, they tell us that this is not simplified. I've looked it up, I've talked to people and everything else, and I can't really get great explanations on why this is not simplified. I think people go back to, well, before they had calculators, it was hard to figure out what it was, and blah, 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 because you're dividing by a square root. Nowadays, you can always just chuck it into a calculator, get an answer in about 2 seconds, and you're good to go. But you're going to have a lot of teachers that will not allow you to write the answer like this, and I'm going to be one of them, all right, because I just want you to be ready for other teachers that may not want you to keep it like this. All right, so I think it's important that we learn how to simplify them, not for any real practical purpose, but just so if you have a teacher that makes you do it, you'll know how to do it. All right, and we will learn this in a little bit. So these are my 3 basic rules of simplifying radicals. Okay, you can't have a perfect square inside of a radical. You can't have a fraction inside of a radical. And you cannot have a radical in the denominator. Now, can you have one in the numerator? Can you have the square root of 5 over 3? Yep, that's perfectly fine. That right there is simplified. This is not. It's kind of weird, isn't it, that they don't let you do that, but that's the rules, and we got to live by them. All right, let's talk about square roots right now and simplifying square roots. So let's do the one they give us. And let's change colors. The square root of 45. Well, actually, before I do this, I'll keep that there. But before I do this, there's a rule, and they call it the product property, or the product property of square roots, or something like that. But it goes something like this. If I have the square root of a, and I'm multiplying by the square root of b. Now you realize that a and b represent just regular numbers, okay? I'm allowed to do this. If I have two separate square roots multiplying times each other, what I can do is this. Make just one big square root and put both of those inside of the square root. You see what I did? I took two individual square roots and I took the a and the b, I multiplied them together and I put it under just one big square root. And you can go the opposite way. If I started off with this right here, I could always split it up. And that's what I'm going to do here in a second. If I have two things that are being multiplied together, I can split it up into their own individual square roots. Do you see that? I took this one big square root with a times b inside of there, and I split it up so that I have two individual square roots. So for instance, if I had like the square root of 3, actually let's do this. What if I had the square root of like 2 times 3? Or even better than that, what if I had the square root of 6? I could break that down, couldn't I? What's equal to 6? Well, 2 times 3. I don't know why I'm writing uphill, but I am. Okay, what's the square root? The square root of 6 is 2 times 3. That's the same thing. What does this rule say that I can do with these numbers? The rule says that if these two are being multiplied together, they have to be multiplied, not added, but if they're multiplied together, I can break them up and put them under their own square root. So I can go square root of 2 times square root of 3. This rule, this product rule for square roots allows me to do that. You're like, well, why would I want to do that? That's kind of silly. Why don't I just keep it the square root of 6? And you're absolutely right. If it's a square root of 6, you can't really simplify that any further, so there'd be no reason to do this. But we're not always going to deal with something that's already simplified. We could come across something like this, square root of 45, and you can break it up and you can simplify this. This you really can't simplify. It's already done. All right, so let's write it down again. Have a little clean slate here. So let's put that square root of 45. There's a couple ways you can do this, but I'm going to show you the way that I like to do this the best. Think of two numbers that multiply to be 45. Well, there's probably several numbers. There's 9 times 5. That's kind of obvious. Let's see, 15. 3 goes into this, right? 15 times, 3 times 15. I can't think of anything else. But those are our choices. And sometimes you have a lot of choices, sometimes not so many. But what I want to do is I want to pick the choice so that if I take the square root of one of those numbers, I'm going to be able to get a whole number out of it. One of those numbers is a perfect square. So which one of those, 9 times 5 or 15 times 3? Is there a perfect square in there? Yeah, I think you know what it is, don't you? It's 9 times 5. And that's kind of nice. 9 times 5 is 45. So this is exactly the same thing. Now remember that product rule I just talked about? This is why I want to apply that product rule. This is kind of cool. So the rule says that if I have two things multiplied together inside that square root, I can split them up into their own individual square root. So watch, I could rewrite this as what? The square root of 9, and I can write this as the square root of 5. Now you're thinking, why would I want to do that? Well, hopefully you see it. Hopefully you see why I wanted to do that, because look at the square root of 9. The square root of 9 can be simplified, can it? The square root of 9 is just a 3. What number times itself is 9? 3. What about 5, though? Is there anything that some people might say 5 times 1, but are those two numbers the same? No. What number times itself? What two of the same numbers multiply to be a 5? I can't think of any at all. There's no whole numbers, okay, that work. So all I would do is just write the square root of 5. So the square root of 45 is the exact same number, right there, with a little arrow. Square root of 45 is the exact same thing as 3 times the square root of 5. And you look at this and you're like, well, that doesn't look any better than this. I'd rather just have one number under the square root. That looks more simple to me. But remember, you can't have any perfect squares inside the square root. This was a perfect square, so you have to simplify it. Okay, you got to break it down. That's what I say. And the square root of 9, you got to make into a 3, because that was our first rule that we talked about at the beginning. And now it's simplified. All right, let's do this. Maybe you don't believe me that it's simplified. Let's actually use a calculator just to see. Let's tell you what, let's scooch some stuff over just so I can see that whole thing. Let's scooch this over there, and let's bring that calculator up again. There we go. Now it's a little better. So let's put some numbers in here. Now, I wouldn't normally do this, but I just want to prove to you that square root of 45 and 3 square root of 5 is the exact same number. So let's put the square root, there's the square root of 45 in here, and see what we get. 6.708, I'll keep that up there. Now let's put 3 times the square root of 5. I can just hit 3, and then I don't even have to hit the times on this calculator. I just hit the square root button, then I hit 5. See, that's the same thing as this. So the square root of 45 is this number, and this is 3 times the square root of 5. Let's hit enter. What do you think it's going to be? Boom. Exactly the same number, isn't it? All right, so do you believe me now, all you doubters? The square root of 45 is the same thing as 3 times the square root of 5. Hopefully that makes a little bit of sense to you. Now we're going to do another one, and we're going to basically use that rule, that property rule that we just talked about, that product property rule. All right, here's your problem right here, and it says to simplify this, all right? It's not simplified. You're like, why isn't this simplified? That looks like it's simplified. It's a square root of 6. Square root of 15, that's 3 times 5. It doesn't have any perfect squares in there, but remember, I'm multiplying them together, so let's see what we get. Let's just work down, I think would be best. I could break down the square root of 6. Let's do that. What is it? It's 2 times 3, isn't it? And let's break down the square root of 15. Let's break that thing down. What times what is 15? Doesn't have to be something times itself, just what times what? 3 times 5, right? 3 times 5. Now look, this is all being multiplied, isn't it? So what's the rule for multiplication? I can put all those things under the same square root. So I've got a 2, I've got a 3, I've got another 3, and I've got a 5. And they're all being multiplied. That's what those dots are there for. And you're looking at this and you're like, well, wait a minute. It's getting worse. It's looking worse than what I started with. But it's actually going to get better here in a second. Do you notice something? Do I have a perfect square? Do I have a number times itself inside of that square root? Absolutely I do. That's going to be what? 9. 3 times 3 is 9. So what I have is this. After you get better at these, you can skip a little bit of this, but I'm going to do this right now. Watch. This is going to be 2 times 3 times 3, which is 9 times 5. Now I have the square root of 9. I can actually take the square root of 9. Now you could go back and put them under individual square roots. That'd be a waste of time. But watch this. I know this is under a square root, so I have to take the square root of 9. What is the square root of 9? The square root of 9 is a 3. So it's going to leave the square root, and it's going to come out here and just be a regular positive 3 outside of the square root. Okay? See what I just did? Again, if you wanted to break it down, you could go square root of 2, square root of 9, square root of 5 if you wanted to, right? And there's your square root of 9. You know it's a 3. And then you could multiply these together. Square root of 2 times square root of 5, which is just the square root of 10. And now it's simplified. There's no perfect square in here, so now you've multiplied those together. All right? Hope that makes a little bit of sense to you. But I got to move on if it doesn't. Go to Khan Academy and look up radicals or look up square roots, and he'll go through a bunch of these rules for you, and hopefully he can make a little more sense to you. It takes a little time, but if you want to learn this stuff, that's what you're going to do. All right, we're going to try to simplify this thing. This is a little bit tougher, okay? So just bear with me. I'm going to go through it. If you need to pause it and go back and listen, you can. If you want to go to another resource like khanacademy.org, do that as well. But I'm just going to have to trudge through this. So let's see what we got. We've got a big old square root. And what I want to do is I want to break these things down so that I can take the square root of them. I want to get some perfect squares inside of here so that I can take the square root and pull them out front. Then I've simplified it. So let's take 20. What times what? You could use 2 times 10, but I'm going to use 4 times 5. Because why did I pick 4 times 5 and not 2 times 10? Because I know I can take the square root of 4 and it's going to come outside of the radical. Now look at this. Watch very carefully. It's a little bit of a, not really a trick, but kind of a trick to do with this. X cubed, this is a odd number right here, okay? What I want to do is I want to break it down so that I have x to an even power. So watch what I'm going to do. I'm just going to do it. I'm going to write it as x squared times x. Remember, that's x to the first. That's x to the third, isn't it? Why did I do that? Because I want this to be an even exponent, because I can take the square root of an even exponent like this. Because what number times itself is x squared? Well, x is, and then that'll come out front. It's a little confusing if you're not used to these things, but we'll keep going, all right? What about y to the fifth, this one right here? What I want to do is, it's an odd exponent again. So what I want to do is I want to write it so it's y to a even exponent. Okay, what's the next smallest even number below 5? Well, it's 4. So watch what I'm going to do. I'm going to make this y to the fourth times y to the first. Isn't that the same as y to the fifth? Yep. And why did I do that? Because I wanted this to be an even exponent. Look at the z. The z is already an even exponent, so I'm not going to break that down. I'm just going to keep it z to the sixth. All right, so now what we're going to do is now we're going to take the square root. There's several things in here we can actually simplify by taking the square root, and 4 is one of them. So the square root of 4, I'm not going to break it down into their individual square roots, okay? I'm just going to go from here right to the answer. So what's the square root of 4? It's 2. So that leaves the square root, and it becomes just a regular 2. Make sure you get rid of it here. All right. The 5 stays inside the square root. Let me give a little space here. Okay, so the 5 stays inside the square root. What else can I work with? I can work with this thing right here. It's the square root of x squared. So what am I asking? I'm asking what number times itself is x squared. That's what you're doing when you're taking the square root of something. So the square root of x squared, what number times itself? X. X times itself is x squared. So I'm going to put an x right here. And that whole thing turned into an x. Okay, it left the square root, it came out here, and it just became an x. What about this x to the first? It's an odd, so it's going to stay inside the square root because it's not a perfect square. Here we go again. Look, that's a perfect square. Why? Because what times itself is 4y squared, or to the fourth? What number times itself? Well, y squared is. Did you realize that? Y squared times y squared is y to the fourth. So y squared times itself is y to the fourth. So what's the square root of y to the fourth? It's y squared. I know this seems a little confusing for some of you. That goes away, okay? That y to the fourth inside the square root became a y to the second, or y squared, outside the square root. We're almost done. We still have this y, just like we did with these others. It just stays inside of the square root. Okay, so actually let's not cross that out. Let's just keep it right there. All right, and what about the z? Z is to the sixth, which is an even power. So what times itself is z to the sixth? Well, z to the third times z to the third is z to the sixth. So z cubed times itself is z to the sixth. So what's the square root of z to the sixth? It's z to the third. And that leaves the square root, and it comes out here. So look at that. That right there is your simplified square root to this. They're still equal to each other. This is just more simplified than that. Remember at the beginning we said you can't have a fraction inside of a square root? That's why they give you this problem, because this is not simplified. They'll tell you on all these problems, they'll say to simplify. All right, so you can't have a square root. And you're looking at this, well, wait a minute, I can't reduce it. What in the world am I going to do? Do you remember that product rule where you had the square root of a times the square root of b equals the square root of ab? Well, you have a quotient rule as well. So you have a rule that says this. What if I have the square root of a over b? Then you could break it down like you did right here. You could put one square root on the top and then put the bottom square root on the bottom. All right, and you can do this. And you're probably thinking, well, wait a minute. You said you can't have a square root on the bottom. Yeah, but on some of these, it'll work out fine. Okay, just bear with me on this. So let's see what we're going to do. I'm going to apply this quotient rule to this thing right here. So I'm going to put the square root of 25 on the top, and I'm going to put the square root of 16 on the bottom. Now they've rigged these a little bit. Did you realize that? Because you can figure out what the square root of 25 is. It's a perfect square. So what's the square root of 25? It's just plain old 5. What's the square root of 16? Remember we said we don't want a square root on the bottom? Well, they rigged it so that the square root actually goes away. What's the square root of 16? It's just plain old 4. So what's the square root of this 25 over 16? It's just 5 over 4. One of our other rules from the beginning of this lesson was that we can't have a square root in the denominator. And look at that. I got a square root in the denominator. So what do you think we need to do? We need to simplify. Simplify this problem right here. And how do you simplify it? Well, you simplify it by getting rid of that square root. I'm running short on time, so I'm just going to kind of give this away to you. What color? Let's go yellow. What I'm going to do is this. If I take a square root and multiply it by itself, this works for any square root. If I take a square root and multiply by itself, it'll actually get rid of the square root. If you don't believe me, let's do another number. What if I take the square root of 2 and I multiply it by itself, the square root of 2? Look what I get. Square root of 2 times square root of 2 is the square root of 4. What's the square root of 4? It's just a plain old 2. Look what I did. By taking, if I started with the square root of 2 and if I multiplied it by itself, that got rid of my square root, didn't it? Yep. So what do you think I'm going to do here? How do you think I'm going to get rid of this square root? Let's multiply it by itself. Okay, that's going to get rid of the square root. But if you look at this, I can't just multiply the bottom by a square root. I have to multiply the top by a square root as well. If you look at this whole thing right here, what is that? What's anything divided by itself? It's a 1. So I really haven't changed the value of this, but I am going to get rid of that square root. All right? If you don't believe me, just watch. I'll get rid of that thing. So let's put a fraction thing here. Now let's actually multiply here. Let's get rid of that box. We don't need that now. Okay, let's multiply. What is the square root of 3 times the square root of 3? Well, it's the square root of 9. What's the square root of 9? It's just a plain old 3. That works every time. What if I had like a big crazy number? What if I had like the square root of 75 times the square root of 75? You don't have to do any math at all. What did you just do right here? You just got rid of the square root and I'm left with 75. Really what you're doing is you're squaring it, aren't you? When you multiply something by itself. So watch, if I had the square root of 57 times the square root of 57, what basically is that? It's the square root of 57 times itself, or squared. What does that squared do to the square root? It cancels it out. And so I'm just left with 57. That's what I'm doing right here. What about the top, though? Now, they are not the same thing, so nothing cancels out on the top. It's just 2 times the square root of 3, or we write it like this, 2 square root of 3. And that is this simplified. Some of you look at this and say, wait a minute, this looks more simplified than this does because this only has 2 numbers, that has 3 numbers. But why is this not simplified? It's not simplified because you have a square root in the denominator, and they told us at the beginning that they didn't like that. They didn't want a square root in the denominator, and we got rid of it. Pretty cool, huh? Yeah, I think so. Let's do another one kind of like this. Okay, I kind of doubt you did anything quite this complicated when you did this in whatever you did it in Algebra 1. But bear with me, okay? I'm going to go kind of fast, but you always you got the YouTube thing. You can pause and you can rewind and you can listen to me, you know, a few times to try to catch on. So what we're going to do here is this. I want to simplify this thing. First thing I'm going to do is work on this square root of 18. Square root of 18. What times what? Well, I got 6 times 3, but I can't take the square root of any of those. What else do I have? Oh, I got 9 times 2. Excuse me. I got 9 times 2. So let's do that. I'm not going to mess with this top right now. All right, we'll finish the bottom and then we'll worry about the top. So let's simplify the bottom. It's 9 times 2. Now, we just did a whole problem like this. What's the square root of 9? It's a 3. So that leaves the square root and it comes out front. So I just have 3 times the square root of 2. That's the same thing as the square root of 18. Now let's just keep the top the way it was. I'm not messing with that just yet. And there's no way I can get a perfect square up here in this square root because 13 is just 13. It's a prime number. So I can't do the same thing up here. So you think, oh, I'm done. Well, are you really done? No, it'd be nice, wouldn't it? But I can't have a square root in the denominator. So we just finished talking about that. How do I get rid of the square root? I multiply it by itself. And then I do the same thing to the top. Okay, do it to the top and the bottom. And let's see what I get. So let's scooch this over just a little bit. Give me some more room. All right, let's multiply this together. Let's see what we get. We get 3 times the square root of 2 times the square root of 2. Well, what is the square root of 2 times the square root of 2? It's just a 2, right? And that will be a 6. What about this? Look what we can do here. I have a square root times a square root, so I can put everything underneath one square root. So let's do that. Let's multiply all the stuff that's underneath it here. I'll tell you what, let's just go 13y times 2. It's going to multiply those together in this step, but let's go kind of slow here. All right, so I'm allowed to do that. Remember that AB thing, square root of A times square root of B is the square root of AB. It's basically what I did right there. So let's finish this off here. Equals, let's do the bottom. Remember what the bottom was. It's just 3 times 2, which is 6. Let's do the top. I can actually simplify a little bit of stuff inside the square root. I can multiply 13 by 2. 13 times, well, let's put the square root first. 13 times 2 is 26. And then you just have the y right there. And that is your simplified answer. A little complicated. But after you get used to these and you see what I just did right there, it starts making a little bit of sense. But you got to practice it. You can't just look at this and say, oh yeah, I got it. You got to practice. All right, that's the only way that you're going to get any good with this. All right, I have one more type to do, and then we'll be finished. All right, look at this one. You got a square root in the denominator again, but this is a little bit different. It's not just being multiplied by anything. Look, you got this minus sign right here. That makes a huge difference. Now, there's a rule. Now, again, if I was going to teach you this lesson like in Algebra 1 for the very first time, I would take a little bit more time with this. But they only give you the one example, so let's talk about this a second. If you have a minus or a plus, what we're going to do in order to get rid of the square root is we are going to multiply by a thing called a conjugate. All right, we're not going to see this too much in the geometry class, but when you get to Algebra 2, you'll do this quite a bit. Right, multiplied by the conjugate. So if I had something like this, watch, I'm just making this up. What if I had 2 plus the square root of 3? What would the conjugate of this be? The conjugate means everything stays the same except for that thing in the middle. So if that's what we start with, let's just put an arrow. It's not equal, but what would the conjugate of this be? It would be the opposite sign of the middle one. That's all you do. Look, you keep everything else the same, you just change the sign in the middle. So, and I'll show you why this works. It's pretty interesting. What's the conjugate of 5 minus the square root of 2? It's going to be 5 what? You change the sign in the middle, so I'll change it to a plus. Everything else stays the same. Now, just like we did before, if you multiply the bottom by this, you're going to multiply the top by that as well. Now, I know I'm going a little bit quick, especially on this next part, but bear with me. You might need to review it. You might need to watch another video from somebody else that explains this conjugate stuff. But here we go. What I'm going to do is I'm going to multiply these together. Now, the reason I put them in parentheses is because we have 2 terms here, 2 terms here. In Algebra 1, you learn the FOIL method. Do you remember that? Or distributive property. I'm not going to teach it to you from scratch, but I'm going to use it right here. So I'm going to go FOIL. First, outside, inside, last. So I'm going to multiply the first terms together, which is 25. I'm going to multiply the outside terms together, which is 5. It's positive 5 times the square root of 2. I'm going to multiply the inside terms together. That's going to be a negative 5 square root of 2. And then I'm going to multiply the last terms together. Now watch very carefully. It's a negative times a positive, which is a negative, and it's the square root of 2 times the square root of 2. We've done this a couple times already. What's the square root of 2 times the square root of 2? It's just plain old 2. That's how you do the bottom. Now the top is just a regular distributive property. We just take a 3, because it's just a one single number. It's not a binomial, and we just multiply by everything inside this. So 3 times 5 is 15. Plus 3 times square root of 2 is just 3 square root of 2. We're almost there. Bear with me. We're almost done. Now, you can't simplify the top. You can't add those together. They're not like terms. This is already simplified. Let's do the bottom, though. Look at this. Positive 5 square root of 2 minus 5 square root of 2. That cancel, that cancel. Look what you're left with. 25 minus 2. What's 25 minus 2? It's 23. And now that's your final answer. I know, I told you, it's a little bit crazy. And some of you guys are okay with this. Some of you guys remember this from Algebra 1. Some don't, okay? Sometimes you don't see this till you get into Algebra 2. So like on a quiz or a test, I'll try to make it as easy as I can, all right, with still covering the material. But there you go. That's how you do the conjugate. I'm telling you, look it up. Look it up on khanacademy.org. And his videos aren't near as long as mine. They're usually like 10 minutes long. And watch what he does with this, and you might make a little more sense with it. All right, well, I hope that helps. That definitely was a little bit tougher, that lesson right there, out of all the ones that we've done on this chapter 0. But we are finished. Thank goodness we're finished chapter 0. So we'll be ready for a test pretty soon. But just listen in class for the instructions on when it's going to be and what review we're going to do and all that good stuff. But congratulations for finally finishing chapter 0.